Unit 3, Limits Day 6. Let's go ahead and pick this lesson up where we left the last lesson off. We were looking at making piecewise functions continuous at specific values. So let's remember what our technique was. To make a function continuous, we need the left-handed limit to equal the right-handed limit to equal the value of the function at that point. So we are saying that we have the limit as x approaches, in this case, -1 from the left of f of x. That has to be equal to the limit as x approaches -1 from the right of f of x. So since we are dealing with two polynomials, we directly substitute in. So we're going to get x squared plus k over 2. Woo, that's a 2, I promise you. K over 2 equals k over 2 times x plus 5, and we're looking at the x value of -1. So let's directly substitute that value in, and let's get -1 quantity squared plus k over 2 equals k over 2 times -1 plus 5. And let's simplify. -1 squared is +1 plus k over 2 equals k over 2 times -1 is negative k over 2 plus 5. So I'm going to add a k over 2 to both sides because I'm trying to combine like terms, and I'm going to subtract a 1 from both sides. So a k over 2 plus a k over 2, think of it as like 1/2 plus 1/2 is a whole. Well, half of a k plus half of a k is a full k. So k equals my 5 minus that 1, k equals 4. Let's double check and make sure that this is accurate. So what we're saying is x squared plus 4 over 2 equals 4 over 2x plus 5 when x is -1. So -1 quantity squared plus 4 over 2 is 2 equals 2x. Oops, and instead of x again, we are saying -1 plus 5. Is this a true statement? Well, -1 squared is still +1, so we have a 1 plus 2 is 3 equals 2 times -1 is -2 plus 5 is 3. So that did indeed make this function continuous. So let's now look at this function. Again, same idea. We need the limit of f of x as x approaches 3 from the left to equal the limit of f of x as x approaches 3 from the right. We also need that to equal the value of the function there, f of 3. So let's plug in directly and see what happens. So c times 3 plus 1 needs to equal c times 3 squared minus 1. And so we get 3c plus 1 equals 9c minus 1. Let's combine like terms. I'm going to subtract 3 from both sides, and when I say 3, I really mean 3c. Subtract 3c from both sides, and I'm also going to add 1 to both sides. And when I do that, I get 2 equals 6c. So I divide by 6 on both sides, and I get c equals 2/6, which is 1/3. So again, it's always a good idea to check afterwards, plug in those values, and we do get a true statement. So that is the correct value of c to make this function continuous. So let's look at one more continuity function, and this one looks a little bit scarier, but I assure you it is absolutely no different. Now we are just looking at some generic point A, but again our technique is going to be exactly the same. We need the limit of f of x as x approaches A to equal the value f of a. Now this is a little bit different than those other problems because we're not dealing with an inequality here, but the idea is the same. For a function to be continuous, the limit must exist and it must be the same as the value of the function at that point. So think about our technique for finding the limit as x approaches a. With that buddy right there. X squared minus a squared is a difference of squares, so it's going to factor as x minus a times x plus a over x minus a. And again, we're finding the limit as x approaches a of this function. Recognize that we have x minus a over x minus a whole, so we can take it out and rewrite this as the limit as x approaches a of x plus a. And now we can just directly substitute in a for x, and so we get a plus a, which is 2a. Now, again, for this function to be continuous, we need that to equal the value of the function at that point. We're essentially using the bottom half of this equation to plug the hole. So let's figure out what the value of the function is at the x value of a. Well, I don't even need to write it as a limit. We're just directly substituting in a for that x value. So I'm going to get 3 times a plus 4. And again, I need to set that equal to that feller right there, 2a. So I get 3a plus 4 equals 2a. Let's subtract 2 from both sides, 2a from both sides, and subtract 4 from both sides. So minus 2a minus 4, minus 2a minus 4. 3a minus 2a is a equals negative 4. So even though it looks like a little bit of a harder problem because we have an a instead of a number there, it works exactly the same way. So now let's jump back to where we've been, and let's remember how to solve this problem right here. Well, when we get that fraction in the numerator, we need to find a common denominator. So I'm going to need to multiply this fraction by 2 plus x over 2 plus x, and I'm going to need to multiply this fraction by 2 over 2. And when I do that, I can rewrite this as the limit as x approaches 0 of 2 times 1 is 2, and 1 times 2 plus x is 2 plus x. But I'm subtracting that whole second fraction, so I'm going to get minus 2 minus x all over that common denominator, which is 4 plus 2x. Notice 2 times 2 is 4, 2 times x is 2x, and all of that is still over x. But now look at what simplifies. 2 minus 2 right there. That cancels each other out, so we get a negative x over that 4 plus 2x over an x. And I should write that limit. But again, remember that dividing by x is the same as multiplying by 1 over x. And now we have two fractions, recognize an x and an x. And so we get the limit as x approaches 0. Whoa, that's an arrow, I promise you. Limit as x approaches 0 of negative 1 over 4 plus 2x. Now we can directly substitute in to get negative 1 over 4, because we get 2 times 0 there, which is 0. So the limit as x approaches infinity, as x approaches 0, of this function is negative 1/4. So now we're looking at some weird limit that we haven't looked at before, but it actually has huge implications for calculus that we will get into later. But for now, let's just play with this limit using what we know about limits. So notice I have a delta x down here, and I'm looking at the limit as delta x goes to 0. So again, I can't just directly substitute in because my denominator would equal 0, which is not allowed. So let's go ahead and simplify the numerator. Notice I have a 2 times that quantity there. Let's distribute that in and find the limit as delta x approaches 0 of 2x plus 2 delta x minus 2x all over delta x. Well, notice this is pretty nice because I have a positive 2x and a negative 2x. So I'm simply left with the limit as delta x approaches 0 of 2 delta x over delta x. And what happens? Well, delta x over delta x cancels out, and so I see that the limit is simply the number 2. Not so bad, right? Well, let's do another one. It's the same exact idea here. We want to simplify this and see what cancels out. So let's think about that x plus delta x quantity squared. Well, when you FOIL this out, you're going to get an x squared, you're going to get 2x delta x terms, and you're going to get a delta x quantity squared term. So simplify that, and we will get the limit as delta x approaches 0 of that whole mess right there, which I'm going to be lazy and copy and pull down like that. That whole bit, and then we have a minus x squared from that dude right there. All of that over delta x. And again, let's look at what cancels. Well, I have a negative x squared and a positive x squared, and that is the only bit that cancels this time. So let's rewrite this as the limit as delta x approaches 0 of 2x delta x plus delta x quantity squared all over delta x. Well, I could write another step, which might help you in the beginning to see. Notice that I have a delta x factor in each of my numerator terms, so I can factor out that delta x, and I'm left behind with a 2x plus 1 delta x, and all that's over delta x. Well, I can now eliminate that delta x and rewrite this as the limit as delta x approaches 0 of 2x plus delta x. And I can directly substitute in. My delta x is 0, so I get 2x. And you might be like, well, that's weird. I have an x in my answer. Well, you should. Alright, another one of these crazy delta x problems. Our technique is going to be the same. Distribute or FOIL and simplify what you can simplify and rewrite the limit, see what cancels out. So the limit as delta x approaches 0 of x plus delta x squared. Well, we just did that on the last page. That's going to FOIL out to x squared plus 2x delta x plus delta x quantity squared minus, let's distribute in that 2 to get minus 2x minus 2 delta x. Don't forget to make that delta x negative as well. And then I have a lonely plus 1. And then I'm going to distribute this negative into each of those terms to get negative x squared. Negative 2x is positive 2x and a negative 1. And all of that is over delta x. And you might be pulling out your hair because this is so messy. But again, notice I have a negative x squared and a positive x squared. Let's see what else I have. I have a positive 2x and a negative 2x right there. I have a negative 2 delta x and nothing to cancel with that. So I'm going to keep that. I have a positive 2x delta x and nothing to cancel there. And I have a delta x squared, nothing to cancel it, but I do have a positive 1 and a minus 1. So let's rewrite this as the limit as delta x approaches 0 of what's left over, 2x delta x plus delta x quantity squared. What else do I have? Minus 2 delta x, all over delta x. Now I can go through and I can factor that delta x, but I can also just cross one delta x off from each term. So that guy is gone, one of those is gone, and that guy is gone. So it's going to simplify to the limit as delta x approaches 0 of 2x plus delta x minus 2. And now I can directly substitute in 0 for delta x to get 2x minus 2. And that is my answer. You should not have a delta x in your answer, but you should have an x. One more of these, and now recognize that we have a fraction up there, so we're going to use our technique of multiplying by the denominator of the other fraction. So I need to multiply that by x plus delta x plus delta x. I need to multiply that simply by x over x. And let's see what happens. So in the left fraction numerator, and first again, let's rewrite our limit. Delta x approaches 0. Left numerator, I'm going to get an x times 1, gives me an x. minus the other bit, which is going to give me x plus delta x times 1. And so don't forget I'll then need to distribute that negative in to both of those terms. And all of this is over x times x plus delta x. And all of that is over delta x. And let's acknowledge the awesomeness that's about to happen. X minus x eliminate each other, and we just are left with that negative delta x. So that uber numerator is negative delta x over x times x plus delta x over delta x. Well, again, we know that that delta x is going to cancel with that delta x because we could rewrite it as a product of the reciprocal. And so we're going to get the limit as delta x approaches 0 of negative 1, because we still have that negative up there, negative 1 over x times x plus delta x. Well, we can directly substitute in for delta x now, and we will get negative 1 over x times x, or more prettily written, negative 1 over x squared, and that is our limit. So you may have noticed on the previous problems that we have similar things here. 1 over something, 1 over something, something squared minus 2 times something plus 1, something squared minus 2 times something plus 1. You didn't realize it, but you were doing problems like this. So this is saying find the limit as delta x approaches 0 of your function with an x plus delta x plugged in minus your function f of x. So again, just like this, if this said f of 3, you would take 3 and plug it into the x value, the x spot in your f function. Well, we're doing the same thing here. We're just evaluating it for x plus delta x. So I'm going to write my limit as delta x approaches 0 of my function with that x plus delta x plugged in for the x there. So I'm going to get 4 times x plus delta x, close my parentheses, plus 2, minus my f of x function, I'm going to put in parentheses, is 4x plus 2, and all of that is over delta x. So again, let's go through and let's simplify things and see what cancels out. So distribute in that 4, I get a 4x plus 4 delta x plus 2 minus 4x, distribute that negative and get minus a 2 all over delta x. And look at what cancels. Positive 4x, negative 4x, positive 2, negative 2. So I'm just left with that 4 delta x. So I get the limit equals the limit as delta x approaches 0 of 4 delta x over delta x. My delta x's cancel, and I'm just left with 4. 3 more of these to look at. Again, same idea. We are finding the limit as delta x approaches 0. Wow, my pen's not working well. Limit as delta x approaches 0. We need to take x plus delta x and shove it in for x right there. So we're going to get 2 times x plus delta x, quantity squared, plus 3, minus our entire f of x function, so throw it in parentheses, 2x squared plus 3, all over delta x. So remember again, x plus delta x squared is going to give us an x squared plus 2 delta x times x. That I'm going to write that as 2x delta x, so you don't think you can multiply those x's together, because you cannot, plus my delta x quantity squared. And so that's all going to be multiplied by that 2 right there. So I'm going to rewrite this as the limit as delta x approaches 0 of 2x squared plus 4x delta x plus 2 delta x quantity squared plus 3 minus 2x squared minus 3, because again you have to distribute that negative into both of those terms, and all of this is over delta x. So again, notice what cancels. I've got a positive 2x squared, a negative 2x squared, I've got a negative 3 and a positive 3, and that should be everything. So let's rewrite this limit without those things that just canceled. Limit as delta x approaches 0 of, I'm left with 4x delta x, and I'm left with a 2 delta x squared, so plus 2 delta x quantity squared, all of that over delta x. So again, I can eliminate my denominator by crossing off a delta x in each term, and now I can rewrite this as the limit as delta x approaches 0 of 4x plus 2 delta x. Directly substitute in 0 for delta x to get the limit to equal 4x. 2 down, 2 to go. Again, the same idea. Limit as delta x approaches 0. Maybe you remember from science class what delta x is referring to. Maybe you can think about what f of x plus delta x and f of x represent, and maybe you can find a deeper understanding of what this problem is actually doing. That would be cool. But we'll get there eventually. So again, take x plus delta x and plug it in for x, but notice we have 2 spots to plug it in for x this time. So the limit as delta x goes to 0 of 3 times x plus delta x squared, so 3 times x plus delta x, quantity squared, minus 2 times x plus delta x. Notice I'm putting it in for both spots for x, minus my function, which is 3x squared minus 2x, all of that over delta x. So again, remember x plus delta x squared is going to is going to expand as x squared plus 2x delta x plus delta x quantity squared, and I'm multiplying that by 3. So I'm going to get the limit as delta x approaches 0 of 3x squared plus 6x delta x plus 3 delta x quantity squared minus, distribute in that 2 to both, and negative 2, so minus 2x minus 2 delta x, and distribute in the negative to each of those terms to get a minus 3x squared, and a negative 2x gives us a positive 2x there. All of that over delta x. And again, tons of stuff's going to cancel. Positive 3x squared, negative 3x squared, positive 2x, negative 2x. So I'm left with the limit as delta x approaches 0 of 6x delta x plus 3 delta x quantity squared minus 2 delta x, all over delta x. So again, to eliminate that denominator, I have to pull out a delta x from each of those terms, and I can rewrite this as the limit as delta x approaches 0 of 6x plus 3 delta x minus 2. And now I can directly substitute in a delta x value of 0 to get 6x minus 2 as the limit of this function. And finally, one last one for the evening. Limit as delta x approaches 0. I'm bad at drawing those arrows still. Limit as delta x approaches 0 of the function 1 over x plus 3. With that x plus delta x substituted in for x, so I get 1 over x plus delta x plus 3, and I'm subtracting from that f of x, which is 1 over x plus 3, and all of that is over my delta x. So again, this should look pretty familiar. And remember our technique for handling a problem like this. We're going to multiply each by the denominator of the other, so x plus delta x plus 3 over x plus delta x plus 3. This guy over here, we're going to multiply by x plus 3 over x plus 3. Boom. So let's simplify it and see what we get. Limit as delta x approaches 0. My left-hand fraction, numerator, is going to give me an x plus 3. My right-hand fraction, numerator, and notice we are subtracting it, is going to be parentheses x plus delta x plus 3. And all of that is over this ugly mess, which I'm not going to multiply out. I mean, I could, but it doesn't do me any good. all of that over delta of x. So again, hopefully my numerator simplifies to just a delta x or maybe a minus delta x. Well, look at this. Distributing that negative right there, we're going to get a negative x, a negative delta x, and a negative 3. And I'm going to get a negative x canceling with my positive x right there. I get a negative 3 canceling with my positive 3. And so I'm just left with that negative delta x. And negative delta x, that delta x is going to cancel with that delta x. And holy moly, limit as delta x approaches 0 is going to be negative 1 over x plus 3 times x plus delta x plus 3. Sorry, I ran out of room there. But the point is, we can now directly substitute in delta x for 0. So I'm going to get negative 1 over x plus 3 times that delta x right there is going to 0. So I get another factor of x plus 3. So I can write this as negative 1 over x plus 3 quantity squared.